Howdy students, this is going to be a continuation of video part 3 where I'm just going to work on drawing the Lewis dot structures for these compounds. And so if you need to, pause the video. There's going to be a couple of times where I'm going to tell you to pause the video and just keep up or pause the video when necessary, really. Okay, first example, CH4. Remember, first thing, this is a covalent compound. How do I know that? The key is that you're looking to the elements above the staircase on the periodic table with the inclusion of hydrogen. So all these examples are going to be elements. Carbon's up here. We have hydrogen, so this is a covalent compound. If you have a metal, you're going to draw the Lewis dot structure differently. Just keep that in mind. You got to know the distinction between the two types of compounds. Okay, CH4. Step 1, I'm going to count up the valence electrons. Carbon is in group 4, so it has 4 valence electrons. Hydrogen is in the first group, it has 1, but I have 4 of them. So I have 4 plus 4, which is going to give me 8 valence electrons to work with. Step 2, I have 1 carbon and 4 hydrogens. So I'm going to put the carbon in the center, and I'm going to space out. Let me draw this a little bit bigger. I've got plenty of real estate here. I'm going to draw the hydrogens spread out. Step 3, my favorite, connect each element with the other with single bonds. Step 4, I'm going to make sure that every element has the right amount. Hydrogen follows the duet rule. So each one has 2 next to it. Each line represents 2 electrons, remember. So each hydrogen has 2. So it's good. Now how about the carbon? The carbon needs 8. It follows the octet. If I look, this carbon atom has 2, 4, 6, 8 around it as well. So it's good. So my final structure is CH4 drawn like this. And sometimes you'll need to clean it up. But this is my correct Lewis dot structure. Okay. Next example is CO2. Carbon dioxide. I'm going to count up the valence electrons. Carbon has 4, oxygen has 6. There are 2 oxygens though, which gives me a total of 12. So 12 plus 4 gives me 16 valence electrons to work with. So let's move through it. Carbon is going to get drawn in the center. Oxygens will get drawn on the sides. Step 3, I'm going to connect each element with a pair of electrons using a single bond. Step 4, I need to go in and make sure that everything has the right amount. So remember, each line has 2 electrons. So this carbon has 2, 4. So it needs to have 4 more to have 8. So I have to come in and draw 2 pairs. And remember, I draw them in pairs, not single dots, but I'm going to draw them in pairs like this. Okay, how about the oxygens? This oxygen only has 2 around it, so I need 6 more to draw. And this oxygen will be the exact same. Okay, so if I draw it out again, looks like this right now, the cleaned up version. So step 5, I need to make sure that what I drew matches how many electrons I actually have to offer. Did I draw 16 valence electrons? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I drew too many dots. So now I need to go ahead and draw some double bonds. So to do that, you're going to take two lone pairs, and they cannot be on the same element, but they have to be on elements next to each other. And I'm going to get rid of two pairs to form a second bond. It's like in Monopoly when you have four houses, you can make a hotel, kind of a same scenario here. And then I'm going to do it again on this side. I have a choice. I can either do it again on the other side, or, like I said, I can have it symmetrical, and I'm going to use these two here to make a double bond. Now if I go and recount, what you'll see is I have 2, 4, 6, 8, 10, 12, 14, 16, and that matches. So my cleaned up dot structure is going to be right here. This is my final dot structure. Okay, the next one, I want you to hit the pause button and see if you can draw NH3 by yourself. And when you're ready, go ahead and resume the video, and I will reveal the answer here. So here's NH3. Nitrogen's 5 valence. Hydrogen is 1, but I have 3 of them, so that makes for 3. So I have 8 total electrons to work with. The final dot structure, I spread the hydrogens out, connect each one with a line. I'm going to go in and make sure every element has what it needs, and to do that I have to draw 2 on nitrogen. And if I count 2, 4, 6, 8, I've drawn 8 electrons, which matches how many I have, so this is a good structure. No double bonds needed. Okay, next one, CCl4. Go ahead and pause the video. See if you can draw it out, and then I will show you the answer after you resume. Okay, let's go through it. Carbon is 4 valence, chlorine is 7, and I have 4 of them, which makes for 28. 7 times 4 is 28. So total I have 32 valence electrons to work with. Carbon is going to go in the center. Chlorines will be on the outside. I'm going to connect each one with a bond, and then I have to fill in dots to make sure that each chlorine has 8, because it follows the octet rule. Lots of dots. Carbon has 4 bonds attached to it, which means it has 8 electrons there. And if I count up the electrons on each leaf of this drawing, I have 2 from the bond and 6 from the dots, which gives me 8. So each leaf has 8, and 8 times 4, I do have 32 drawn, which matches. So this is a good structure. Okay, next I'm going to work this one out with you. NH4+, this one is new because we have a plus charge. This is an ion, and if you remember, we call this ammonium. It's a polyatomic ion. So we're going to draw a Lewis dot structure for a polyatomic ion. Same process. We have one difference with that plus sign. Nitrogen has 5. Hydrogen is 1, but we have 4. So that's 4 for a total of 9 valence electrons. Nitrogen's going to go in the center. Hydrogens are going to be drawn on the outside. I'm going to connect each one with a line. Everything is satisfied, but there's one more thing we got to go back and check. When I am counting my positive ion here, it's actually going to change. It's going to have an effect on this number. So instead of 9 valence electrons, when we have a positive charge, you may want to write this. Positive charge means that you have lost electrons. A negative charge is when you have gained electrons. So I have my students write this and square it in their notes. So that 9 is going to drop down to an 8 because we have lost 1 electron. So now when I count, I have 8 valence electrons drawn down here, which actually does match the 8 that I counted up. So this is the correct structure. Okay, go ahead and pause the video and see if you can work out this polyatomic ion here, which we call sulfate. And resume the video when you're ready to have the answer. Okay, sulfate, 6 and 6. I have 4 oxygens though, so 6 times 4 gives me 24 there. So I have 30 to begin with, but I have an ion. I have a 2 minus. Negatives gain electrons. So that 2 is actually going to turn that 30 into a 32 valence electrons that I have to work with, not 30. So let's draw it out. Sulfur's in the center. I've got oxygens on the outside. Connect each with a line. I'm going to have to draw in dots for oxygens because right now each oxygen only has 2 with that bond, and I need 8. The sulfur on the inside has 8 as well. And on this one, if we count, we're going to get a total of 32 valence electrons, and it does match. So this is good. There's one more thing that I'm going to add. On ions, we have to draw brackets and put the charge on the outside. So I'm going to go back on the last example, NH4+, and I'm actually going to bracket it in and throw that positive sign on the outside. So you may want to make another note. You're going to have to bracket ions. All right, we have a few more examples here. Okay, go ahead and pause the video in case you need to work it out, and resume the video when you're ready for the solution. This polyatomic ion is called cyanide. Now this one, let's go ahead and count up the valence. We have 4 and 5, which gives us a total of 9. But the negative is going to add 1 to make it 10 valence electrons. Because there's only 1 of each element, doesn't matter where I put them, I'm going to go ahead and connect them together. And I'm going to make sure that each one has the proper amount of valence electrons for the octet rule. When I count this up, I get 10 valence electrons. Excuse me, that is incorrect. I meant 2, 4, 6, 8, 10, 12. We actually have 14. When we draw it, we have 14 valence electrons. So this does not match, which means I need to draw a double bond, which means I'm going to take a pair of each, cancel them out to draw, and I'm going to recount. When I recount, 2, 4, 6, 8, 10, 12, I get 12 valence electrons, which still is no good. So I'm going to have to take a pair and draw a triple bond. And when I count 2, 4, 6, 8, I get 10 valence electrons, which finally is what I needed. I'm going to clean it up. And because this is an ion, I will have to bracket. Last example here on the end of this video will be carbonate. So again, go ahead and pause the video here and resume when you're ready for the solution. Here's carbonate. We have 4 valence electrons. 6 times 3 gives me 18. So that's 22 And I have a -2, which is going to add 2 electrons to give me 24 valence electrons to work with. The oxygens are going to go around the center. Each oxygen is going to need 6 dots, and even the carbon on the center is going to need a lone pair. If I count up how many I've drawn, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have 26 valence electrons, which is too many. So now I have to take a pair of electrons, one from the carbon, and now I have my choice. And the next video is actually going to be talking about something called resonance. So when you have the option to choose from any of these outer elements, we call that resonance. So I'm going to go ahead and take the top one and go ahead and create a double bond there, which will change the number of electrons to 24, which will give me enough. I'm going to redraw this. It is an ion. Double bond here. Bond, bond, and this is an ion, so I need my charge.